Proofs of similarity, guys, is lesson 17, day 3, I think, because we took one day for each of the proofs for the Pythagorean theorem. So, remember, 2a implies all 3a. What does that mean? What does 2a imply all 3a mean? You guys should know this. AA, arrow, AAA. That's angle, angle, angle. Right, but what does that mean?
Two angles are the same, that means all three are.
Right. If you know 2 of the angles in a triangle, by default, you know all 3. Right?
Correct.
Now, what does it mean to be similar again? To be similar does not mean congruent. Congruency implies similarity, but similarity does not, by itself, imply congruency. What is similarity? We took notes on the actual definition, but what is similarity? To be similar. To be like. It's a likeness, guys. All squares are similar. Why? They have different sizes, but they all have the same shape. Right? They all have 4 90-degree angles. All of their sides are the same length. They'll have a scale factor then. Do you guys remember this?
Yes.
And so if they have the same shapeness, means angles, and they have a scale factor between the 2 shapes that's consistent for corresponding sides, then we say it's similar. It says we have postulated that we can state that triangles are congruent by side, 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 angle, side, angle, 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 side, or sometimes we say angle, angle, side, and HL. The SSS and the SAS postulates hold for both proofs of similarity as well. But rather the letter S instead of side, it means that the sides are not the same, but they are proportional. They have a ratio, guys, of like 1 to 2. Or 2 to 1, right? And so, what we're going to do now is we're going to do the same proofs that we would have done for congruency, but instead I want you to prove that these 2 triangles here are similar instead. You do this by a 2-column proof. 2-column proof has what as a setup?
Statement and reason.
Statement and reason. Statement, reason. Number 1, the reason is always given. Now, in this particular problem, and I think the ones that we have, they're not stating it to you as in this is congruent to this or this equals that. It actually is just giving you the diagram. You need to figure out what was given to you. What seems to be given to you in this picture? Angle A. Yeah. Angle A is congruent to angle E. Now, Mr. Konchak, wait a minute. Why are we using congruency stuff inside of similarity? Because to be similar, angles have to be the same or congruent. That's why. There are going to be times when you're going to use congruency to prove things are the same, so we can say they are similar. Okay. 2. Is there anything else given to us? Other than the triangles shape themselves? No. And the really cool thing about this, guys, is that the proofs from before with congruency really do kind of flow interchangeably sometimes with some of the reasons and statements. What else do you see that could potentially be the same? C. I need more than just C because there's, well, 4 angles there, right? Yeah, BC. What? BCA congruent to angle DCE. And the reason? What's that?
Reflexive.
Not reflexive. I liked what Audrey said. What did you say?
No, I said that.
What you? Oh, you said. I thought you said something else. Vertical. I thought I thought I said vertical. It's vertical angles. Vertical angles, guys. Vertical angles are congruent. So, better mark it. Now, we know two of the angles. What can we state now? Angle what? ABC. Actually, do I need to use three letters now? Can I just say angle B?
Can you use
Not two, but one. Why can I use one this time, but last time I used three?
Because you weren't.
You didn't know what C you were talking about.
Right. C has more than one angle potentially. But B, I agree. Guys, if you look at B, everybody can see there's two. There's the minor angle, and then the angle on the outside, which would be the larger one. But since we're talking about these triangles exclusively, would I be talking about the angle on the outside?
No.
No. So, therefore, we can say angle B is congruent to angle D. And the reason for this one? AA implies AAA. So AA with an arrow of A. Okay? Questions on that? So wait, go to my diagram. Double bar. Do I have enough information now to state the given? Or state the proof?
Yeah.
So in step 4, triangle ABC is similar. Remember, that's a one squiggly. Triangle EDC. Reason?
CPCTC. No.
No, CPCTC's corresponding parts of congruent triangles are congruent.
Oh, that's right.
We're not talking about congruency, we're talking about similarity.
Oh, yeah.
Why are they similar? What's the same? The angles. And so the reason we say similarity is by it's either AAA, it's going to be side, 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 or side, angle, side. Do we have any sides in this problem? No. Guys, here's the thing. If you can claim that all the sides have a common ratio, the same, therefore it would be similar by side, side, side. If you can say two sides and the included angle between them is the same, side ratios with the included angle between, they're also similar. You now just proved the similarity here. Do you think you guys can replicate that yourself? Let's give it a shot, okay? Here we go. I'm going to pause it. You guys give it a shot. So, everybody should have statement number 1. What's given to us? AB parallel to
IDE.
DE or ED, it doesn't matter. Given. It's already marked on the drawing. Yeah? Yeah, they're little arrows. I don't know, they didn't come through very well, but they're little arrows. The next thing, I think everybody should be able to get at least this step. What would it be? Angle. I can't say angle C again. BCA is congruent to angle DCE. And the reason? They're vertical angles. vertical angles. Okay, so I'll mark that. But I got a problem then for the fact that there's only one angle. That's not enough to prove that they're the same. And those aren't tick marks. Those aren't saying that AB is congruent to ED, right? But why would it give us the fact that they're parallel? What's so special about parallel lines? Not necessarily. They're not the same. What's the same about parallel lines?
They're never ending. Never touch.
An attribute about lines that are the same. What makes two lines parallel? Yeah, but why? Because they have the same slope.
Nice, Johnny.
Their slope is the same.
Unbelievable.
But I don't think slope's going to necessarily help us right now. So, but we do know that they're parallel. What else are we thinking?
AD, through
The line that passes through them? I can't guarantee that the line A to D is the same as B to E. Because those lines are connected at different places. Now, again, if you turn your paper so that your parallel lines are kind of going across your paper, you should see something that looks like this. Parallel lines. And if I extended one of those, you see this?
Oh, yeah.
So, what are equal and the reason why? What's that? What angles are the same? Angle D is congruent to angle A. Why? They have to equal each other. They're on the opposite sides of the zigzag, right? But what are those called? Alternate interior angles, guys. Alternate interior angles. Alternate interior angles are the same. Now that means B is congruent to angle E. Why?
Because alternate interior angles.
I can use the same thinking, guys, the same reason. They're also alternate interior angles. Or because I get lazy and then stop thinking after I realize that I know two of them. The reason the third one is because AA implies AAA.
So if you put alternate interior angles for
Either one will work.
would you do angle D is congruent to angle A and then slash angle B is congruent to angle E on the same one?
Right, or just put like eliminate 4 altogether. Like
Yeah, that's what I mean, yeah.
eliminate step 4 and put both of those pieces on step 3. I'd be okay with that.
Okay.
Because you're using the same reason.
Okay.
Yes. Did everybody understand what Jake was asking?
Yes.
If I went and said, take out this and all of this, that's all step 3. I am okay with that. Either way, it comes out to the fact that angle B and E are the same. And so, if I put those back on, which I could, I'm going to leave them off. My new step 4 is triangle ABC is similar to triangle DEC. Why? I ran over my space here, guys. AAA. That's it, right? Just all 3 sides are the same. Or angles, sorry. So here we go. Let's set it up. Statement and reason. Number 1, what are we stating? Well, because they're just giving us the diagrams, you probably should go ahead and state that side length of GH is 12, GI is 15, and so forth, okay? So if it's something like this, I think I'm not going to give you guys just pictures like this. I'll probably have it stated saying, hey, given this, show this, and have you put the information on. I was just here to saving some time. So the first thing, you might want to state, I'm just going to save time. Instead of writing it all out, put triangles above. That's not the classic thing to do, guys. I don't want to say spend all the time right now stating that GH is 12, GI is 15, angle G is 30, KL is 8, JL is 10, and angle L is 30. You should be stating all of that. The reason? Given. Does everybody follow that? Okay. 2, because of all that given stuff, what can you say? What looks to be the same? Angle G is congruent to angle L. What's the reason? Both angles equal the measure of 30. Each angle measure is 30 degrees. By definition, they both equal 30 degrees. They have to be equal. Yeah? Now, what did I say about using side, angle, side? Because right now, it's definitely what we're going to use. What do we have to show them? The sides are not the same. They have, though, what? A common, starts with an R. Ratio. They have a common ratio. So in step 3, set up that ratio. State something on the lines of G, H to what?
GH to KL. Is it KL or LK?
Which one is it? Is it LK?
No. Yeah, it would be LK. Right?
Equals what? 12 to 8. And then we have
4.
GI to LJ equals 15 to 10.
Yeah.
What do I have to, was there a reason? Should I simplify those? I don't know if in a statement I can straight away state that those are equal. What should I do with those? Guys, we didn't state anything original. And so, 4, could I now say that, wait a minute, GH to LK is equal to GI to LJ? The reason? 12/8 equals, what's that reduced to? 3 halves? Which is the same as 15 over 10?
Fourth hour.
It's on video. Is everybody okay with that? That they are the same because they equal, the reason? Their ratios themselves equal the same common ratio? And so, you just proved that each of the combination of side ratios to corresponding sides have the same ratio. They have a congruent angle between them. So 5, well, I'm going to put way up top. 5 is what?
Oh, triangle GHI, and then triangle
By
or SAS. Yeah.
SAS. The sides have the ratio with the corresponding angle between them being the same. That means the third set of sides would also have to have that same ratio, therefore they're going to be congruent. Or not congruent, sorry, similar. Okay guys, this is day 3's homework, because day 2 we did not have homework. We just did the proofs and let you guys catch up. Page 131, 4 through 8, 20, and 25. Have a great day.